Climate change is the single greatest challenge that we face as a species. The clock is ticking. We must find solutions now. But the key to climate change is not up in the sky. It is on the surface of the Earth. And the surface of the Earth is 70% water. The key is the sea. In order to predict long-term climate change, in order to understand weather patterns in the ocean, it is crucial to monitor sea levels accurately.
The sea is a major instrument controlling climate change. It's actually a reflection of what is happening in climate change today. The increase in temperature is absorbed by the sea. At the moment, for example, we have 3.2 millimeters per year sea level rise. And people think that's minimal. But this has devastating effects over the coasts. We have sea water intruding into our fresh water. It destroys agriculture, animals, plants, islands may be lost, and people have to relocate. We have standards for the food we consume, standards for pollution. We don't have any standards for the climate at the moment. Altimetry is a technique to measure height from a satellite flying 1,000 kilometers above the Earth's surface with an accuracy of 1 centimeter.
To provide accurate data for the change in sea levels, satellite altimetry has to be continuously monitored and controlled for its quality, biases, errors, and drifts, maintained for at least 20 years and tied from one mission to the next. That is why the European Space Agency created the concept of FRM for ALT. The Fiducial Reference Measurement for Altimetry is a network of calibration validation sites all over Western Crete. This network has been operating for about 2 decades, with a major station on the island of Ravdos and a recent transponder site on the Cretan mountains. Western Crete has been identified by the European Space Agency as a unique location for calibrating satellites that measure sea level change. The sea surrounding the island has minimal tides. The sparsely populated, rugged mountainous landscape has zero interference. But most importantly, in the sky above it, a number of satellite orbits converge.
We had to find a location where several satellites meet at the same point, because we can cross-calibrate each satellite with the next one using the same location, the same instrumentation, the same setting, which is very important. We have an ideal location in terms of satellite crossing on top of a mountain about 1,000 meters high. We have a very deep slope. We can separate the signal from the sea quite effectively here. The satellite is passing this location with a speed of about 70 kilometers per second. The whole duration is about 4 seconds over this area. So in those 4 seconds, the transponder receives those signals and retransmits with no distortion back to the satellite. We check if the range from the satellite to this station is correct or not, and what's the bias or the uncertainty that we have to apply to all the measurements that the satellite is making. That's what we do. It's a simple idea, but has a lot of complicated instrumentation and processing behind it. We have to make sure that the orbit is right. We have to know where the satellite lies when it started to transmit. We have to know where the satellite was when it received the signal. We have to know what's the time it took from the satellite to the transponder and from the transponder back to the satellite. We have to take into account what the station is doing in terms of displacement with respect to the center of mass of the Earth. The internal delay of the transponder itself, the troposphere and the ionosphere delays of the signals, we have to measure that. It's as if the transponder is another satellite on the Earth. If we are to warn people about a disaster, we have to make sure that the numbers are right. We have an undisputable and objective way to observe what the climate is doing today. We have to have a stable ground to do these things, and we have to trust it. We are building that stability in a way that the next generations are going to rely on it.
Climate change is a reality we all have to face. FRM for Alt provides us with the right tools to anticipate this change and prepare for it. SIRAC continues the legacy.